Hi, and welcome to the ONF Spotlight on 5G Connected Edge Cloud for Industry 4.0 transformation. I'm Timon Sloan with the Open Networking Foundation, and today it's my pleasure to welcome Jacob Reeb, who's the VP of Wireless and Digital Services, along with Colin Campbell, the VP of Engineering, both with Cambridge Consultants. Cambridge has been at the forefront of using private LTE and CBRS for innovative digital transformation projects. And the paths between Cambridge and ONF have started to cross of late as ONF's Ether platform has been introduced. And Ether is an open source option for creating such networks. And the alignment between Cambridge and ONF and Ether is notable and exciting. So at ONF, we believe that organizations like Cambridge can help leverage Ether to help unlock the potential for leading organizations. So it's with great pleasure that I welcome Jacob to lead off our program today. Jacob, please take it away.
Yeah, first of all, I want to thank everybody for joining us here today. My name is Jacob Reeb, VP of Business Development with Cambridge Consultants. Today, really what we're going to kind of talk about is the collision between Industry 4.0 and connectivity. There's been a lot of buzzwords and technology kind of flying around on Industry 4.0, from AI to edge compute to intelligent sensors, et cetera, et cetera. And as well as there's been a lot of buzz about private cellular network development, and most recently, $4.6 billion being raised within the PAL licensing for CBRS. And we see that collision, and what we mean by the collision is the fact there's great opportunity for numerous organizations that have been looking for this technology to be able to take advantage of a lot of the technology that's available out there today, companies that are in utilities and manufacturing. But as well as with the environment that we've had in the 2020 year that we've had, there's been a fast forward in multiple other industries like warehousing, logistics, and retail, where organizations have seen the opportunity to fully automate their logistics and warehousing facilities. But the reality of it is the collision of these two has really raised the idea that if you're going to ultimately utilize these technologies, you ultimately do need to figure out a way to build a network that meets the needs of your solutions. So moving on here, where does Cambridge kind of fit in all this? And it's exactly that, is the innovation and the ability to build intellectual property. And for us, being around as long as we've had, and the facilities and the personnel that we have the experience to help these organizations build these customized and innovative products and solutions, and specifically to what we're doing here today, looking at the networks and beyond the network itself to do that. I mean, there are a lot of solutions that are out there that you ultimately put in, we'll cover in a little bit. But really what it comes down to is, how do you start to build your organization to move from innovation and beyond? And there is a stat out there currently today, and other people have heard of it as it relates to IoT, that 76% of all IoT projects have failed. The reason they've failed is that they're the masters of their domain, and a lot of these skill sets that they need are outside of their four walls. So for us, that's exactly where we play. We play in the innovation, we play in that customizability, and filling those skills with personnel and some of the world leading engineers from MIT, Cambridge, and Oxford that work for our organization, and helping those organizations end up building that technology base. Industries do face extraordinary change, and we've talked to a lot of our companies, and this is where the stat comes in, but really, how are you going to execute and create your innovation within private cellular network and within Industry 4.0? There's a lot of consumer off-the-shelf solutions you can put in today, but really what ends up happening is you're building a network that you've been currently leveraging potentially with your MNOs. And then beyond that, what's your capability? What are you doing with AI? What are you doing with those edge compute devices to customize to meet your solution needs? In the industries that we're talking about, from warehousing to manufacturing to utilities, and even in providing connectivity for online education, there's a lot that needs to happen as it relates to innovation and really transforming your organization from being X in an industry to an industry leader, to ultimately becoming an innovation company that potentially builds a platform. And we'll go through some case studies that we have later on within our presentation. But really what this comes down to is, what are the unique skills required? What do you need from personnel? And more importantly, what are some of the key learnings that you could end up having as it relates to building out these networks? At this point, what I'd like to do is turn it over to Colin Campbell to kind of go through some of the learnings we've had within this space, and then we'll kind of come back to some of the case studies that we've seen in these industries to kind of give you an example of what can transpire when you actually leverage both sides of the technology and companies like ourselves. Colin?
Thanks, Jake. That really good introduction. Thank you very much. So yeah, as Jake says, the kind of key that we're talking about here is looking at the way that technology is evolving in wireless, and the very highest level, 10,000 foot sort of level, you're talking about wireless networks becoming distributed data centers. And I think it's worth digging into that just a little bit more. We've heard mention from the ONF, the kind of open source ether, that kind of philosophy is extending all the way through right to the RAN level with Open RAN, and networks becoming software defined right up to the point at which you turn numbers into radio waves and vice versa. So what that really means, and by software defined, I mean we're running software on commodity hardware, and so that means that you are kind of moving into that paradigm where innovation happens at the pace of software, not at the pace of hardware. I mean, we've seen this happen in the cloud domain, and we're all used to seeing our apps update really rapidly, and services that we use on the web are constantly updating. The same kind of principles can apply in the networking side and the wireless networking side, and where you can actually create your own bespoke networks purely by changing the software, and that is from all layers of the software. It's not limited just to the network end, it's also right at the wireless end. But because you're running on commodity hardware, you're also introducing a new paradigm where the networks and the compute really live together, because it's the same commodity hardware, just running different compute functions, different workloads. The network workloads have slightly different attributes that they have to work to, but the compute workloads, the AI, ML type workloads, the web workloads, are all running on the same hardware. And what that really means, particularly when you then bring in the 5G mix, where the flexibility is built into 5G in terms of how you distribute that processing. You're talking CU, DU splits, where some of the processing is expected to be centralized, some of it's expected to be distributed, but there's flexibility on where you can move that processing. You can do the same with the compute. You can have compute in the cloud, you have compute in the centralized network node and an edge network node, and then right at the edge on the kind of mobile edge nodes. And those kind of flexibility gives great opportunity, but it comes with some constraints in that final connection that from the mobile edge to the first network node is wireless, and wireless brings its own challenges that really need expertise to know, well, what kind of wireless network do I want to have? What do I really need to get out of my wireless network in order to deliver the service that I want? Another aspect that is worth mentioning here is that all this flexibility means that actually you can, as I say, you can innovate and change what your network is doing, and you can use well tried and tested techniques from the software world, like build, measure, learn, and you don't have to be fixed with your network is not fixed. It's not a fixed function network. It is now truly a flexible network that works with the compute that you're trying to achieve. So just try and bring that to life a little bit more with some examples. Work. So we look at automating warehouses, and one way in which you can automate warehouses is having a centralized brain, where you're creating an intelligence in the middle that is really instructing and optimizing where all the machines or the robots in that warehouse are moving around to collect goods, transferring goods, etc. The challenge there is achieving high connection density with high reliability, because if you're telling things, machines what to do and when to do it, you've got to do that reliably. It's got to be very, very low latency so that those messages get there on time, consistently. Now, why is that a challenge? If you look at typical mobile phone densities, What we're looking at is a network where, if you look at the kind of densities that you would expect in a sports stadium that is fully occupied, which hopefully we'll see again soon, if every single one of those people try to make a call at the same time, the chances of those calls actually being successful is extremely low. Yet in a warehouse, that's exactly the situation that you're creating. You've got the same density of connections, but every single one of those calls has to get through all the time. So you have to look at using your network to create that predictability, design it in through low-level customizations, through increasing the density of the network nodes, or even, as I mentioned earlier, about distributing where the compute is, move some of that brain, some of that compute out into the edge nodes. That creates its own, the mobile edge nodes, not the network edge nodes. But that has its own constraints of power and compute density that you can get. Another example, this is slightly different, but similar, in looking at, instead of a really constrained area, looking at a broad area. So monitoring and controlling of remote assets. So typically you're looking at trying to provide high capacity coverage to areas that are really remote. So you're trying to get as much coverage as possible with the high capacity, because there are bound to be loads of sensors and actuators and things that you want to monitor and control out in those remote areas. You typically have an additional challenge of the backhaul from your network nodes is low capacity, because people haven't put fiber out into the towers yet. So you've got to balance this need for high capacity coverage, long range, high capacity coverage with low capacity backhaul, which probably means moving some of the decision making closer to the edge, getting some really smart antennas in there so that you're not trying to light up the whole of Nebraska just to get coverage along the single pipeline, for instance. You can use smart antennas to get the coverage just where you want. And as I mentioned earlier, because it's software, you can continuously adapt and optimize. So you can start by laying out the network that you think is the right one, but learn from that layout and optimize in the places that really need optimize and adapt it to meet those changing needs. A lot of what we're talking about here is really about intelligence. It's about the compute. It's about getting the connectivity and the compute really working together as a tightly coupled unit. So making both of those elements of the service or system that you're trying to create really part of it and not separate things that evolve at their own paces. So looking at co-designing those together, looking at rolling them out together, upgrading them together. You also, as you're moving AI models to the edge, you need to look at optimizing those models to run on the limited resources at the edge. That's exactly the same challenge that you have with the connectivity. Connectivity is extremely high performance compute, just like AI models are. They have slightly different characteristics, but ultimately they need to be optimized to run on low capacity resources at the edge. And training and adaptation then becomes a problem, because the more you move the intelligence to the edge, the less ability you have to move all the training data back to the cloud to train. So you have to work out how you're going to collect the right data, only the data you need, how you're going to learn on the edge, but then distribute that learning widely. There are well-known techniques that do this, but this is all part of the toolbox that you can bring to solving these really unique challenges that you have. With that, I'll hand over to Jake.
There we go. Thank you, Colin. I appreciate everything you were speaking on there. And as far as the next slide that we have here, as I usually joke, this is the obligatory kind of NASCAR slide, but the reality of it is, every single one of these companies that are listed here are organizations we've been engaged with to kind of work with them to create innovative products, create defendable positions in their industry, and ultimately change their way they go to market. And ultimately, one of the stats that we had up earlier is that 70% of our client base is repeat customers because of the work that we do and the understanding of the technology that we understand. But more importantly, as I kind of move along here, and I alluded to this earlier, the case studies. I challenge everybody, if you one is that Cambridge is here to help you, with your customization of your network, and also customization of your end nodes, anything that's beyond the network, ultimately helping you create that innovative product and solution to your industry. The second would be go to our website. Go to our website and check out these different case studies that we have from companies that we've been able to work with, being able to create an antenna array that covers 800 and some odd miles in one plane. And being able to do 5G connectivity, to being able to work with a company that was an online grocer and then ultimately become an online grocer platform, which has a lot of relevance on the warehousing and logistics side, to being able to work with organizations to build the world's largest push-to-talk network within Iridium. We've taken on some of the world's hardest challenges, and we've showcased a lot of our case studies within our website. And on top of it, there's a lot of relevance as it relates to what's happening today at the network level, as well as the end nodes and the solution that companies are trying to accomplish within their industries. And that's really what we were talking about today. Moving on to the next slide. If anybody has questions or comments, definitely reach out. How do you engage us and where do you engage us? You can engage us if you're just reviewing technology, kind of trying to understand exactly what's going on in the space and what's possible. You can engage us if you're actually going into a feasibility study and helping us, engaging us to help you understand, are you going down the right path? You possibly have already decided and move forward and are on that version 1.0 or 2.0, and they're trying to understand, where do I go from here? How do I make this scale? These are all areas within our company that we can help you grow within what you're trying to accomplish. So at this point, I'll turn it back over to Timon and kind of get into the Q&A.
Jacob, thank you so much. That was terrific, and Colin as well. Really, appreciate you being here, and I think that the content and your focus and your expertise is so right on point with what's going on in the industry at large, with the whole CBRS movement and private LTE opportunities, and what's going on at ONF with Ether, bringing open source solutions to this space. And so, the way I hear you talking about it is, building custom networks for custom solutions and custom applications. I suppose my first question, since it seems like you've been at this for a while, identifying the need for custom networks in various forms, why not Wi-Fi? Why not using carrier-provided 4G or 5G? I think, Colin, you mentioned a little bit about just maybe density and sort of the need for mission-critical capabilities. But if you'd say a little bit about Wi-Fi, maybe that would be helpful.
Yeah, I think that's exactly it. We typically find people use Wi-Fi. It's a natural choice when you're trying to do something new. Wi-Fi is available. It's well understood. It's free. But as soon as you trying to have anything beyond best effort, so anything where you want something guaranteed, whether that's bandwidth or latency or reliability, whatever it is, then Wi-Fi really just falls apart. I think we've probably all experienced that nowadays with all these Zoom meetings that we have. If you're on Wi-Fi, it can be a bit tricky. So when you're building that into your business application, you can't do that. You have to have the reliability and the latency. You have to have something that meets your requirements.
Yeah, and I'll jump in there too. As far as like Wi-Fi, I think the one thing that I've come across this recently is the thought process of just connectivity for online learning that a lot of educational systems are trying to roll out, and they're taking consumer off-the-shelf solutions and kind of relying on and making the same mistakes that you kind of look at for public Wi-Fi. Right. I mean, public Wi-Fi has scalability issues. It has security issues. Right. I mean, you jump onto the network, it is really slow, and many of us don't go back to it. That in a nutshell is something you have to review. And as well as there's been numerous articles on the security even for educational systems and malware jumping onto these systems. So there's a lot to think of that, you know, a lot of these organizations need help with. When you get into the cellular world of an M&O, you know, you talk to a lot of these companies, and really what it comes down to is the fact they want to own their own destiny, and they also want to own their data. And that is becoming a mantra for a lot of these companies as they start to move forward in building these solutions out. The issue again is the fact that these companies that, for example, that either have Spectrum or are looking at Spectrum don't have a lot of experience. They're non-operators, and you know, Open RAN and open source, it gets them so far, but there has to be some type of company in between to help them with that innovation, help them with that customization.
Hmm. Yeah, very good. So I can see that for sure. And I guess you've described a role for Cambridge, helping with the innovation, the visualization, all the way through implementation. What about the next step, operationalization and the long-term maintenance and upgrade cycles? I mean, how do your typical clients and customers deal with that part of running a custom network?
Colin, you want to take that, or you want me to jump in there?
I'll let you jump in.
Yeah, I mean, so from our side, there's multiple ways we could potentially do it, right? I mean, without a doubt, there could be off-the-shelf either solutions or companies and partners that we engage to kind of help out and manage those networks. Again, you're ultimately asking an IT network or IT network manager or an organization to move from being a manufacturer or utility to now managing a network. And that becomes a big piece. So we do have partners in the background, but as well, if the case is unique enough and there's certain things that need to happen, we can either leverage, as we talked about, open source solutions, or if it's even more unique, we could look at building a specific solution to the needs of that organization. So there's lots of opportunities out there. I think the one thing to keep in mind is the success of our client as they roll this out is our success, right? That's what we look at. Again, the majority of our customers are repeat customers, and we want to make something that not only works, but also scales and they understand. So when we actually get engaged with this client, we try to understand their needs and what the best technology would be for that organization as they start to move forward.
Right. Yeah, what I'm so excited about is it sounds like Cambridge really has this unique, very powerful set of skills to really build custom solutions. And that bringing an end-to-end open source 5G plus edge cloud capability, making that available, that really gives you all the tools and knobs. So rather than, I think, Colin, you were describing using special antennas to optimize coverage for, I think, a pipeline you mentioned or something.
Yeah.
You know, what we're imagining and seeing now is being able to get all the way down into the programming to handle things like interference or handover or beamforming, you know, and to give you all those tools so that you can really go in and optimize networks for any particular vertical application. You know, we're really hoping that you and others will take advantage of that. And we're imagining that this is kind of opening a door to a new era where the network can really be, you know, definable and customizable. You know, the potential, we think, is unlimited in many ways. Does that sound, you know, am I on point?
Yeah, I think you are. And the one thing to keep in mind too is, you know, Colin kind of talked about, and I have too, about this private network idea and how companies are rolling this out. But as things start to move along, it also could become a revenue source for a lot of these organizations, opening it up and splitting it to a public network. Utility, knowing they have access in rural areas that typically do not have access, without a doubt could be done. And again, as Colin talked about, either beamforming or the specific solution and rolling it down a energy line is fantastic, but then potentially using the public side. And that's the one thing I think is really interesting about this is that a lot of these solutions could end up being revenue opportunities for organizations. And again, you know, working with companies to kind of figure out exactly how to make that all happen is going to be critical.
Mm-hmm.
I think the bit you touched on there, which is really exciting for us as well, is again that kind of comparison with the cloud. There's a whole bunch of open source software and frameworks and everything that you can build on, and you know that's what has really enabled the innovation in that space to happen. So you don't have to create from scratch. You don't have to start on bare metal just to do the small bit that you really need. You can build on a broad ecosystem of well-defined, well executed, well used software and hardware, and then adapt the bits that you need to adapt, but only those. So and that's what we do. We bring that kind of knowledge and capability to be able to allow our clients to, what we call innovate in that kind of 10%, the last 10% where they really need to.
Yeah. No, I love that. Yeah, that's how we describe it as well, that we try to build open source consortiums to work on, we call it 80%, but that's sort of 80% common, non-differentiating platform. And then to enable, innovators like you to then, create that icing on the cake to really, do something unique. And you're absolutely right. ONF has been after this for almost a decade now of trying to harness the approach that the cloud operators and hyperscalers have developed, and be able to apply it in the telco space. And we're really, we've done it with great success and deployments, and our platforms are getting used, all over the world. And we're now taking all of that and making it available in the enterprise space. And so in a way, it's really helping to create, a bridge there and making it possible for enterprises and partners for enterprises such as yourselves to really bring all that cloud-like capability and mindset to be able to build custom solutions that clearly have been the backbone of the differentiator for the cloud operators, right? Being able to do, innovate rapidly in the IT space is becoming more and more, perhaps the single most significant differentiator for companies. And so by owning your own network, by being able to build something custom, by having it open so that you can go in and innovate, we just think it's a tool that can, for leading organizations, is sort of a grand enabler in this whole Industry 4.0 space.
Yeah, I mean, it becomes a grand disruptor, right? I mean, that ultimately is what's going to happen here for a lot of these organizations. And I think what you're going to have is a lot of leaders, and then several of the laggers wondering, we should have done something to move this forward. So, there's a world of opportunity. We're excited about it. Yeah,
no, fantastic. And so we're really excited to have, started to establish, more lines of communication with you guys. I think that, we just see the stars aligning in so many ways. We feel like we're, building these components, and we're really excited to see what you can go out and do with them in many ways, So I think the next year is going to be fascinating. And hopefully maybe we'll come back in a year and kind of do a follow-up here. I mean, I hope we have some case studies that have really leveraged these capabilities and really sort of blown the doors open to enabling new innovative solutions.
Yeah, I mean, without a doubt, we'd be happy to. And I agree with you. I think there's going to be a world of opportunity in 2021 where we can start to execute some of the dreams of the organizations that are out there.
Great. Well, thank you both for joining us today. Really appreciate you being here.
Thank you.
Yeah, thank you.